Hello everyone, this is Yunsong Zhao, and this is my final project, Face Recognition System, the Facebook project. Firstly, let's talk about the core problem statement of the face recognition system, data. And the goal of my project is to build a face recognition system to recognize face for the classmate. In the real world, the face recognition system always meets with the challenge that there only exists one or very small number of symbols to represent a person's face. And in that case, traditional deep learning algorithm cannot make sense. Therefore, the face recognition system always use one-shot learning methods. Well, the one-shot learning methods refer that such learning algorithms can generate from a few or single simple to new situations. For the face recognition system, most of the one-shot learning methods are based on differences of the face images. And then, in my project, I will use the triplet network, one of one-shot learning method. And there is the introduction of triplet network, as you can see. It consists of 3 subnetworks which share arrays and take 3 input data points at a time: anchor, positive, and negative. The goal of the network is to learn a feature space in which the distance between the anchor and the positive is minimized and distance between the anchor and negative is maximized. And as you can see, the loss function is here, and I will try to minimize the loss function. And the importance of my presentation is to show my structure of my algorithm, so I will introduce it. I firstly will preprecise the raw data size to train the triplet network. For training the triplet network, the data size need to be divided into 3 parts: anchor, positive, and negative. Besides, as deep learning network, the data size need to be divided into training data size and test data size. Meanwhile, I will set the random seeds. That's because setting a random seed ensures that every time the code is run, the data is speculated in the same way. And then, with the triplet loss as a loss function, the triplet network will be trained to get the image encoder in that feature exactor to get the image differences. And since the triple network cannot directly classify the face images, rather it can find out distance between the input images. Therefore, I will just use the triplet network to get the image encoder, or name the feature exciter. Specifically, when the input images represent the same person's face, the network will learn the animator, including the weights and the bases, to minimize the distance between the feature of 2 images. In contrast, when the input images represent the different person's face, the network will maximize the distance between the feature of the 2 images. Oh, well, with getting the image encoder from the triplet network, the differences between images can be easily calculated. Then I will set the seed sort to check the face images whether from the same person or the different person. in that when the differences will be smaller than the seesaw, the label will be the same. Well, the differences over the seesaws, the label will be different. And as you can see, the importance of my system is how to train the better triplet network. So let's talk about it. Well, in this part, I use the exception model as the base model, which is always used to image classification tasks. And the expression can be called by TensorFlow in Python. It's my code side. I use the pre-trained model on the ImageNet expression. And for the parameter of the expression, the weight is ImageNet. The include top is false. Means that the output layers cannot be included in the load model. And the plotting is AVG. Refers that I will use the average plotting method in the load model exception. And after the pre-trained model exception, the feature exciter also consists of two full connect layers and L2 normalization layer to normalize the data merely. Specifically, after pre-trained the model exception, the next layer is flatten layer, which takes the output of the expression and flatten it into a 1D array. It will be helpful for the next step. And then the full connect layer is serial, whose activation function is reveal RELU. The dice with 512 numerals can be added, and it adds a batch normalization layer, which helps to stabilize the learning by normalization the input layer by resorting and rescaling. And the other full connect layer is zeroed by batch normalization layer. This dense layer is with 256 numerals and use the same activation function as before. Finally, connect the layer to normalize the vector. That's my triplet network model. And then let's talk about the model result. Since my laptop cannot provide stronger compute power, I just set the approach is 10 for training the triplet network. And I showed two indicators in training loss and testing accuracy to represent the performance of trained triplet network. These are broad result images. It can be found that the overall performance of my model, it looks great, I think. Specifically, the training loss is a measure of how well a model's prediction match the actual target values in the training dataset. In that, the lower training loss, the better model. As the image shown, the training loss is continued decreasing ranging from 0.5 to less than 0.1. That means with the approach increasing, the performance of model in the training dataset will be better. And then you can see the other image, testing accuracy. It will represent the performance of model in testing datasets, which is important for a specific deep learning network. That's because the testing accuracy shows the model generalization ability. It can be found that the test accuracy is always around 0.9, which is enough higher. That means such trained triple network model has stronger robustness and generalization ability. After training the network, I can get the feature exciter from it. As my code shown, the feature exciter is the layers in which the trained triplet network removes the input and output layers. Then I will apply the seesaw method. That means I will compare the differences between images with seesaws set by me. Then it shows result. For the result, I used the testing triplet datasets to evaluate the performance of the face recognition system. I input three types of data, as you know, anchor, positive, and negative, into the network, which is consists of the feature exciter and collecting the differences and seesaw the methods. Finally, I use the confusion matrix to visualize the performance of the face recognition system. As you can see, the middle one is biased and the seesaw is set 1.4 and the accuracy is the 0.814 and for the seesaw is 1, 1.4, 1.8. The accuracy of the model is 0.79, 0.814, 0.796. That means it will be affect the output results of the model whether the seesaw value is too large or too small. Specifically, the seesaws are too small that the true similar will be smaller and the false similar will be larger. In contrast, the seesaws are too large, the true difference will be smaller and the false difference will be larger. Therefore, choose the proper seesaws is important for my system face recognition system, I think. Finally, as for my future work, I think in my project, the results are not accuracy enough to apply on the commercial situation. I think the main reason is that the seesaw methods cannot perform well, regardless of the specific image cases. Besides, since there exists noisy and category overlap in the real data, traditional triplet loss maybe cannot perform well. So firstly, for the loss function, the soft triplet loss may be performance better, which introduced a softened bond that allows for some degree of overlap. That means even if the distance of the negative symbol pairs are slightly smaller than the distance of the positive symbol pairs, this does not quickly lead to a maximum loss. The loss function is here. It's the soft triplet loss. And then for the mixed seesaw, I will find the better method, the directly seesaw method. I find a method that can then dynamically updating of seesaws specifically. So the seesaw is dynamically adjusted based on the data encountered in the real-world application in real-world data sets. That's all. It's my final project with recognition system. Thanks.